This video is going to explain about optimal range and also how enzymes can be destroyed if they're too far outside of their optimal range. So what optimal range means is that enzymes have environments where they function best in, or they're the most efficient. The main environmental factors we focus on with enzymes is temperature, pH, and salinity. So let's look at one example of an enzyme that's found inside of the human body called pepsin. Pepsin is an enzyme that is a digestive enzyme, meaning that it is found in the stomach and it actually helps break down proteins into amino acids. Because it's breaking something down, this is an example of a catabolic enzyme. Because pepsin is a stomach protein, it actually is optimal or works best in acidic solutions. And pepsin is one of the enzymes in our bodies that can withstand the most acidic environment, being, our stomach acid. So its optimal pH is actually going to be around 1 to 2. And because it is inside of a human being, the optimal temperature for pepsin is going to be around 96 to 99 degrees Fahrenheit, or our body temperature. I'm going to ignore the salinity for pepsin for now, but we will be talking about salinity in class. So, the main question is, if pepsin works best in 1 to 2 pH and around body temperature, what happens when you go outside of the optimal range? So, when an enzyme is not in its optimal environment, what's going to happen is it's going to decrease in efficiency, or it's not going to work as quickly or as well as soon as you go a little bit outside of that optimal environment. This basically means that that enzyme is turning substrate into product a lot slower. And if you go too far outside of the optimal range, it doesn't just slow down, the enzyme actually denatures or falls apart and causes that enzyme to be damaged permanently, and it actually stops working altogether. So basically, denaturing is when the bonds between the amino acids that make up our enzyme, because remember, enzymes are proteins. So when the bonds between the amino acids break because of, maybe they're in the wrong pH or the temperature increases too much, it's going to cause the active site of the enzyme to change completely, which leads to an efficiency dropping to 0. So I've drawn a couple pictures. So when the bonds between those amino acids break and it changes the shape of the active site, you go from a normal situation where the substrate combine and then it turns into product, to this, where the active site is deformed because the amino acids and those bonds have changed. And this is called denatured. So the substrate can't bind and actually gets rejected. So it tries to bind here, but it can't fit. So it just bounces off, and that enzyme is useless now. So it can't function at all. So let's look at one example. We'll go back to pepsin and see, where is pepsin going to be denatured, or where is it not going to work very well? So we know that the optimal pH is 1 to 2 and the optimal temperature is 96 to 99 degrees. So when you take pepsin and you put it into a very basic solution, or a solution that is 8 to 14 pH, it's going to denature in this form. So because that's so far outside of the optimal range, it's going to completely destroy pepsin, and it's going to be permanently damaged and never work again. So, in a pH from 3 to 7, pepsin's still going to work. It's just not going to be working as well. So it's not quite denatured, but it's also kind of sluggish. It's kind of moving slow. It's not really turning reactants into products as fast. With temperature, we know that if you get super, super cold, you can die of hypothermia. And if you're super, super hot, you can die of heat stroke. So temperature is going to affect enzyme function in both hot and cold temperatures. So our pepsin is actually going to denature in a temperature of about, 104, 105 degrees Fahrenheit, depending on the person, which would be a dangerously high fever, which is why if you have a fever that high, hospital visit is probably the best idea. And they actually will put ice packs on you if you go into the hospital with a fever that high in efforts to cool you down so your enzymes inside your body don't start denaturing. Also, if you go too cold, so if your body temperature falls below even 90 degrees Fahrenheit, you're going to start really experiencing, you're going to feel tired. Your enzymes are slowing down as you kind of slowly start to freeze. So both of those are going to denature and damage in your pepsin enzyme, and actually all of the enzymes inside your body have a similar optimal temperature, just because your body temperature is pretty uniform throughout all of your organs. It's not like pH, where your stomach has a really acidic pH and your intestines have a more basic pH. So it kind of changes depending on the organ. With temperature, all of your enzymes are going to denature at high temperatures and low temperatures, which is why it is very important that you maintain that 96 to 99 degrees Fahrenheit, or else you're going to start feeling kind of crappy. So just like pH, if you're not too far outside of the optimal range, so if you have a temperature that's, a little bit below 96, so like 94 to 95, you might feel kind of sleepy or tired, but you're not going to be in danger of dying. Same thing with like 100 to 102 degree fever. You're just going to be feeling super tired and sick, but you're not going to be in danger of denaturing your proteins. So that's not really hospital visit worthy. Whereas like 105 degrees is going to be very, very dangerous because you're at risk of damaging and doing permanent damage to your enzymes. So just for the test, I might give you a chart that shows enzyme function on the y-axis and maybe pH on the x-axis with like a graph like this, so that the pH within this range is optimal, and then anything outside of it is going to be the danger zone for that enzyme. So we'll do practice with that in class, but just a heads up that you will probably see something very similar to this on the test, whether in an essay or in the multiple choice. Just telling me that you can read the graph and know, okay, this is where it's optimal, this is where it's not, and where enzyme function is 0 is going to be where it is denatured. So just know that an enzyme is going to denature when it's outside of its optimal pH, temperature, and also salinity as well. So don't forget about salinity. And that's going to wrap up this video.